Hello, my name is Harry, and here is my charge tapes lab. The purpose of this lab is to observe the transfer of electrons and to determine the amount of excess charge on a piece of clear tape. We will first go through the introduction, then the experiment and results, and then a computational model. So the fundamental principles that were used and the mathematical relationships are Coulomb's law, which states that electric force is equal to a constant times the product of two charges divided by the distance in between them squared. We will also be using Newton's second law, which states that F equals ma, Newton's third law, which states that every force has an equal and opposite reactive force. The assumptions I made for this lab were to ignore air resistance, to treat each tape as a point charge with all the charge at the center of the tape, and that each U-tape had about the same amount of charge evenly distributed. Some of the observations that I made when exposing the U-tape to different charged items was the plastic pen, which is negatively charged, the U-tape strongly attracted to, and then a book, which is neutral, the U-tape was attracted, and the U-tape, which we are trying to figure out, is what was strongly repelled by the other U-tape, which leads me to conclude that the U-tape is positively charged. Something important to consider is what if the electrons had positive charge and protons had negative charge, and the observations that would be made in the experiment. So those would actually remain the same because the opposite charges would still be attracted to each other. And as to why it's important to handle the charge tapes as little as possible is because your hand will actually neutralize these charges and make them weaker, so that the observations in the experiment would not hold true. For the procedure, as seen on that diagram on the left, lay a base tape strip on a flat surface. Make two U-tapes by sticking an approximately 8-inch long piece of tape to the base and ripping it. Then to test the charge, place your hand near the tape and then suspend one U-tape on top of two raised surfaces. Hover the second U-tape below until the first U-tape raises up. The experimental data that was gathered was the tape length of 0.2032 meters, tape width of 0.02 meters, tape mass of 2.032 times 10 to the negative fourth kilograms, and distance between U-tapes 0.0305 meters. And one of the observations was that the momentum of the tape is not changing, so the net force equals 0. Here are some of the calculations. There was just some conversions from inches to meters, centimeters to meters, and then the mass was determined between a relationship between the length of the tape and the mass. And then also the distance as well was converted from inches to meters. There you can see the force of gravity being calculated on the bottom left, and the overall charge that you're seeing was calculated down there on the bottom right. Here are some more calculations that take the number of electrons, determine the area, and number of atoms there as well, and then the ratio between the atoms to deficient electrons is listed there on the bottom line. The results from this experiment are listed here in these 5 bullet points. The gravitational force listed as a 3-dimensional vector, and then the magnitude of charge on the tape, the number of deficient electrons on the tape, the number of atoms on the tape, and the ratio of deficient electrons to atoms. And these are all calculated on the previous 2 slides as shown earlier. Here is the GlowScript code that was used to calculate the net electric force using similar calculations as listed earlier. And then when this code is run, it will output this image here, and those green arrows you see are the electric forces that are acting on the particle, and then the red is the gravitational force, and then those vectors are all summed together to calculate the net electric force. And also the ratio of deficient electrons to atom is also included in the calculation, which is listed calculated in the code model as well.